The third one is to check the restore sequence. Now, what do I mean by this? Are you sure if you're taking care of that SQL Server instance, are you sure that nobody else has taken an out-of-band backup or an ad hoc backup? And you look at it this way. You create a job, you create a database maintenance plan that takes care of backing up your database, and you know your restore process, your restore sequence depends so much on that particular backup job. Whether it's a combination of full, differential, log, file group backups, you know that your restore sequence, your disaster recovery sequence will depend highly on that particular job. What if this happened? What if your developers took ad hoc backups off of your production database? A typical scenario. I mean, when I was a data center engineer, this was a common thing. Every 4 weeks, the developers would ask a copy of the production database, restore that into UAT or development environment, scramble the data, and then play with it, introduce some of the features, fix some bugs, and so on and so on. But here's the thing. Let's say your developers don't have any access on the production database. Well, if I'm responsible, I'll just give them a copy of the latest full database backup. That way, I don't have to generate a new one. I'll give them a copy of the latest full database backup and let them work with it. Now, that's easier said than done. But what happens if your developers have a way to log into your production database? The reason I say that is because back when I was working as, again, a production DBA, the developers actually introduced a feature within the application that takes a backup of the database and then copies it to a file share. I'm not aware of it. And so without me knowing, my backups are now being broken out of the sequence that I know it's supposed to follow. Of course, here's the thing. When the developers take a backup of the database, they copy it onto UAT or dev, restore the backup. What do you think they're going to do with that particular backup? They might delete it because they don't need it anymore. Besides, it's taking up so much space on the dev environment or the UAT environment. And they're not going to care because they already have a copy of the database that they need to work with. And so what happens is, of course, they're just going to delete that. Well, unfortunately, your backup and restore sequence depends on that full database backup. Keep in mind that the full database backup becomes the starting point of any other type of backups. And so make sure that you are aware of some of these ad hoc or out-of-band backups that are happening. Now, in a very tight environment where nobody else can access the production environment except you, the DBA, that's well and good. But it's always safe. It's safe to always check whether or not your restore sequence would work. And let's say that I will create a new database maintenance plan, just for the sake of doing a new database maintenance plan. Let's call this DB backups. And I'll call this full. And I will create or add a backup database task. And what I'll do with a backup database task is I will add a new database, the testdb3 database. So this database is a good working database. It's not corrupted. I'm going to add that in. Of course, for simplicity's sake, let me just check the verify backup integrity, but at this point, it really means nothing unless I enable the backup checksum option. But let's put it there for the sake of showing the demo. And I'll add another subplan. I'll call this Differential. Because I've added 2 plans, one the full underscore backup subplan and the diff underscore backup subplan, it will now create 2 SQL Server agent jobs for me. So let me add a task in here and say backup database task. And what I'm going to do is I will generate a differential backup for the same database. Let's say this is a very large database, and to make sure that I meet my recovery objectives, I am going to create a combination of full and differential backups. Of course, you could do a daily full backup and then a weekly full backup and a daily differential, maybe a couple of SQL Server transaction log backups in between. But again, that's beside the point at this case. I wanted to show that if you're not aware of what's happening within your backup sequence, your restore or your disaster recovery process might not work. Let me quickly save this. Let me start off with running the backup job. Now, I mentioned earlier that I have a full and a differential. Let's start that job. At this point, I'm not worried about whether or not the backup is valid because this database is fine. Although, as a best practice, make sure that you include the backup checksum option as well. Let me run that. So let's assume that somebody actually kicked off a job, and that job is taking an ad hoc backup of that particular database, and you're not even aware of it. Let's run the differential backup this time. Again, just because it's running on a regular basis and the job completed successfully. Now let's try to restore the backup using the full and the differential backup that was generated. If you're the DBA, you're thinking, well, if I have a combination of full and differential, all I need will be my latest full database backup and my latest differential backup. And I'm back online. Let's try restoring those backups. So I got a restore command, restore database command. I will provide the file name for my full database backup here. I'm going to copy the file name. Same thing with the differential backup. All I'm doing at the moment is just copying the file names. And let's run our disaster recovery scripts. I'm assuming that you already have a disaster recovery process in place, and all you're doing is just plugging, the file names of the backups. You can automate that process as well, but for the purpose of this demonstration, let's run our latest full. So this is our latest full backup, and this is our latest differential backup. I'm only using the replace option, but you don't have to do that as part of your disaster recovery strategy. Let's run these 2 commands and see how they work. Note that the differential backup failed, and it says, well, this differential backup cannot be restored because the database has not been restored to the correct earlier state. Now, you might be thinking, well, I'm the DBA. I'm supposed to know exactly what's going on here. How come my latest full plus my latest differential doesn't work? Well, your message actually tells you something about this not being the latest full. And how do you check your restore sequence? Let's take a look at the backup history. The way to do that is to check your backup history on a regular basis. And by doing so, you get an idea of something that could be out of the ordinary. Let me run this real quick and show you what I mean. Look closely. You got full, you got differential, same database name. But look at this. these two appear to be similar in terms of the location of the backup device. Contrast that with the second one, which is a full database backup, which is stored on a different location. As I mentioned, this could be a situation where your developers will take a copy of the a database backup, generate a database backup, copy it off to the dev environment, the staging or UAT environment, and just delete it because they don't need it. At that point, they've already done what they need to do. So now your differential backup is now dependent on this, the backup that they deleted because they don't need it anymore, instead of this. So it's important for you to constantly check for your backup sequence because you're probably not aware of what's going on your databases on a regular basis.